So S is the score on a dice. So we've got probability is just 1/6, 1/6, 1/6, because it's a fair dice. And if I want to find out what the expected value of that, well, we know what the expected value of dice is. We know it's 3.5. But we could just do this times this all the way through it to get it. And the variance, I put X there, didn't I mean S? The variance, so if you did want to do the formula for that, sort of this times this and work it all the way through, I'll just do it on the calculator quickly here then, putting all the values in there and calculate one variable statistics. I've got 1.707 as my variance. Menu 1, bring that back up. Variance statistics result, actually no, wrong one, X variance, and the variance squared there is 35 over 12. It's actually a formula for that, n squared take away 1 over 12, which I don't remember whether it's on the formula or not, on the in the formula book or not. But, so the variance is that. Now, using the central limit theorem on a sample of how many? 45, sample of 45, then the mean will be normally distributed with a mean of 3.5 and a variance of 35 over 12 times 45. And we want the probability that S, the mean, is less than K to equal 0.05. So let's grab our calculator for that. We're going into our distributions menu and we want normal less than, so the mean, the standard deviation is the square root of open brackets 35 divided by 12 times 45, and we'll stick a 3.5 in there to start with, and we want this to be 0.05, and so the value for K I'm getting there is 3.0812. 3.0812. Is there anything else I need to do for that? That seems a lot for 8. That doesn't seem enough for 8 marks. Okay. Explain the relevance of the central limit theorem. So we used CLT since n was large. N was large, it was 45, so we could do that because it's quite big there. And the central limit theorem allowed us to use of the normal distribution. 2 marks. So I've got to write 2 things. So I think 1 is large and 1 is that the means will be normally distributed using the central limit theorem. So part C, we've got H0 is that it's fair, and H1 is that it's not fair. So the power of the test, the power is the probability of rejecting H0 given that H0 is false. So what are we doing there? H0 is rejected, so we are rejecting if we are less than 3.1 or more than 3.9, given that H0 is false. So if it's false, we've got this new distribution, haven't we? And they've told us that. So that is normal with a mean of 4. And the variance, so the variance was 3. So, but we've still got to divide that by the 45 of them there, haven't we? So 3 over 45. Right. I think we're ready to do that. look, rather than do this in two separate stages, I'm just going to do 1 minus the probability that it's between the two of them. So I'm going to work that out there. Let's go for it. So my bit I'm going to go between 3.1 and 3.9. I've got a standard deviation in the new one of 4 divided by 45 square rooted, and the mean wasn't actually 3.5, it was 4. So I've got the probability of that happening as just 0.349. Basically, there's nothing at the upper end, is there? So 1 minus the variables statistics result distribution P gives it so 0.65098, 0.651 is my power of my test there. Last bit. So what would happen if we increased the number? If n increases, then the standard deviation, which is 3 over n, that would decrease. And if that would decrease, then the probability of this bit here, so it would get, the distribution would get closer together, wouldn't it? And so we'd get more in here, and so the power would increase. Yeah, let's just see what it looks like on the calculator. So look, this is what we had before, the 0.349 there. So if I say decrease this standard deviation a little bit, then that 349 now changes to 308, so that's smaller, so that's bigger, so the power increases. If we changed it down a little bit more, again, that's gone down, so that's gone up, yeah, so the power would increase.